Hi everybody. So in this video we're going to look at the variance and standard deviation of a dataset. And the standard deviation is the average distance from each data point from a mean of that dataset, and the variance is the square of that distance. So if you want to work along with me in this video, you can download a copy of this PDF from my website. I'll leave a link in the description below. So we're going to begin by explaining the formulae for the standard deviation and the variance, and then we're going to look at how we apply that to various datasets. So to derive the formula for the standard deviation, we're going to consider this dataset, where the purple circles are the data points and this red is the mean. So to work out the average distance of each of these purple points from this red one, you can see this point as a distance of 1, and so does this point, but this one is -1. And this point will have a distance of 3, and this one -3. And each of these points will have a distance of 5. The problem we have is to work out the average distance, we would have to add up each of these distances. And you can see that when we add the -5 to a +5, we get 0, -3 plus a +3, and -1 plus a +1. So the average distance would be 0. Well, if that was true, then each of these purple would be in line with a 0, which they clearly aren't. So the way we turn each of these distances from a negative into a positive is we square each of these. So what we're looking at is the distance between the mean average and a general data point x. So x bar would be our average value, and the x would be the observed value. Then we would sum up each of these distances, and to make sure that each value is positive, we square the difference. And then to find the mean, we divide this by the total sample size, which we call n. In this case, n would be 6. But the problem is, this doesn't give us the standard deviation, and the standard deviation is the average distance of each data point from a mean. What this gives us is the variance. So we say that this is equal to the variance of our dataset x. And to work out our standard deviation, which we call sigma x, this will be the square root of a variance. Because by square rooting this square, we go from finding the mean of the squares to finding the actual distance. So this is one way of working out the variance. A more common way is to find the mean average of the squares minus the square of a mean. So you can work out the variance using either of these formulae. And then to work out the standard deviation, you simply square root each of these. Okay, so in our first example, we've been asked to find the variance and the standard deviation of this dataset. And I'm going to use this formula here. So the first thing I need to do is to work out the average, and that will give us this part, which is the total of all the x values divided by the sample size. So we'll say this is the sum of the x over n, or x bar. So we'll find the sum of the data, and then divide it by the sample size of 7. So this will give us 47 over 7. And now we need to find the mean of the squares. So if I work out the squares of each of these, and then divide that by the sample size of 7, we get 395 over 7. And now we can substitute each of these values into this equation. So our variance will be 395 over 7 minus the 47 over 7 squared. We can work this out and we get 11.34. And then to work out our standard deviation, we'll have the square root of a variance, and this will be 3.37. So what this standard deviation means is that each data point varies on average 3.37 from the mean average. Okay? Let's try another question. So in our second question, we're told that the mean daily temperature in degrees Celsius was recorded for 12 days in July 1987 at Heathrow, and the data is summarised as the sum of the t-values is 45, and the sum of t squared is 180. we've been asked to find the variance and the standard deviation using these two formulae. So perhaps you want to try these questions yourself. You can pause the video, and when you come back, we'll go through the worked solution. Okay, so welcome back if you had a go. So to work out a variance, and we say the variance of t, we need the sum of t squared, which we're given here as 180, divided by our sample size of 12, minus the square of the mean average, and the mean is the sum of the data divided by the same sample size. So this will be 45 over 12 all squared. We can work this out on our calculators and we get 15 over 16. So this will be our variance. Then to work out the standard deviation, we'll square root 15 over 16 and this will give us 0.968 to 3 decimal places. Okay? Okay, so let's try one more question. So in this question, we've been asked to work out the variance and the standard deviation from data presented in a frequency table. And we follow the same formulae, but now rather than just adding up the x values, we need to remember that there's 3 lots of this 1, 4 lots of this 2, and 6 lots of this 3, and so on. So we need to adjust our formula. So we'll say the variance of x is now the sum of x squared multiplied by the frequency over n minus the sum of xf, or x times the frequency over n, squared. And we know that this is still the mean average. And once we've worked out the variance, the standard deviation will be the same, square root of that variance. Okay? So the first thing I'm going to work out is this average here. So xf will be 3, 8, 18, and so on. We'll add all of these up, and this will give us 57. Then we'll work out x squared, and we'll multiply each of these values by the frequency. And when we add each of these up, we get the sum of x squared f as 207. So our variance then will be 207 divided by the total frequency. So we'll find the sum of all of this. We get 19 minus the 57 over 19 squared. When we work this out, we get a variance of 1.89. So the standard deviation will be the square root of this, which is approximately 1.38. So that tells us that the average data point from a mean is 1.38 units. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, you can download the full lesson and the PDF that accompanies this video from my website, mrmathematics.com. I'll leave a link in the description below.